Awesome. Today's webinar is about something that I'm really excited about. I know everyone at Unstructured is really pumped to see. It is the structured data extractor and how we are helping teams fully automate end-to-end critical workflows. But before we dive into the content, some quick intros on our side. My name is Kevin, and I am on the go-to-market team here at Unstructured. I am cosplaying as a webinar host, and I am joined by my better half, Daniel, who is a principal solutions architect at Unstructured, and he actually built the first prototype of the structured data extractor. So thank you for being here, Daniel.
Thank you, Kevin.
Today, we are going to be covering a little bit of background on Unstructured and why we care about this problem. We are also going to be talking through what is structured data extraction and how do we think about it. And then Daniel is kind enough to do a demo of the product. And then we'll finish things off with some Q&A. Some quick housekeeping items. Chat goes in the chat box. There is a different tab for questions if you want us to get to those at the end of the webinar. We will send a recording in an email with some resources to play around with Unstructured after the call. And if you do have any use cases or questions about some of the things that you're building, please go to our website. We have a lot of AI experts standing by, and we would love to connect. Awesome. A little bit of background on Unstructured. We started 3 years ago as an open source library looking to answer the question, do companies struggle to take unstructured documents like PDFs and convert them into a structured output to power various AI applications? If you flash forward to today, it's been a really wild ride. We have tons of amazing customers, 40 million product downloads. We just launched our end-to-end enterprise platform. And we have some amazing partners who are helping us in this mission to make AI accessible. Next slide. So with that, without any further ado, Daniel, do you want to get into what is the structured data extractor?
I do. Thanks, Kevin. So hi, everyone. Thank you for joining today's webinar, where we're announcing our new structured data extraction feature of our ETL Plus platform. So as Kevin said, my name is Daniel Schofield. I'm a principal solutions architect at Unstructured, and I'm excited to be giving this webinar today because I honestly think this is one of the coolest new features of our platform. So I also want to start with a little icebreaker just to get some activity in the chat and make today's session more interactive. And that icebreaker is, if you had to estimate how much more efficient overall AI has made your workflows, what would you estimate that percentage to be? Is it 1%, 5%? Or if it's too difficult to think about it in those terms, maybe it's like 10% of your tasks have been made 50% easier or faster. So go ahead and light up the chat with those estimations and any pertinent colored commentary you want to add to your figures, and we'll see what comes in. And please put to everyone. I'm not sure if it defaults to that or if it goes to hosts and panelists. Well, I'm seeing some numbers come in. Got already quite a range. So I see mostly positive percentages, which is good. No negative percentages. We clearly don't have any anti-vibe coders in the group. Okay, so the reason for this question is that I think we can all relate that one of the promises of AI is around increased productivity, right? So we should all be able to achieve more faster with the help of AI, and it should make us individually more productive. But as organizations, especially given the potential for automation that AI unlocks, we should be seeing significant boosts in productivity with the help of these AI tools and systems. But even today, nearly 3 years after the launch of ChatGPT, organizations are still only at the tip of the iceberg and actually realizing significant productivity gains in a lot of areas of their business. And one of the areas where most of those productivity gains are going to be realized is in the unstructured data space. And that is because most of the majority, if not the vast majority of the data that flows through an organization is unstructured. Slack messages, emails, slideshow presentations, and so on. Unstructured data is flowing all around us, and it contains the business critical information that typically needs to be processed by humans. And what are we humans actually doing with all this unstructured data? Well, the goal of any form of unstructured data passing through an organization is typically to transfer key information from one place to another, with the ultimate goal being that from that, there results some sort of ideally positive operational transaction or simply action that benefits the business. So those actions can be anything from sending a crucial email to a customer that helps to close a deal, or opening a customer support ticket, and so on. So in thinking about how and where productivity gains can come from with a Copilot or AI system helping us to process all this unstructured data, it's important to understand the nature of unstructured data itself and its role in the organization. So I'm going to sum up what I believe those qualities to be with 3 bullet points here. But before I do, let's first quickly touch on structured data, the golden child, just for comparison's sake. The part of the iceberg above water in this visual. The structured data portion of an organization is typically more obvious to build automation and data pipelines around. And that's because it's more reliable to work with structured data. First of all, because it's also basically the core business data that your organization is engaged with. It's recording your business transactions, it's your customers' data or your product interaction data. So nearly all of it is inherently gold. With unstructured data, there's a lot of noise to filter out before you get to the gold. And historically, that's been nearly exclusively a job for humans. But why is that? Well, going to our first bullet point here, that's because most unstructured data is directly from human origin. In other words, it was typed, spoken, possibly even handwritten, and it's also typically intended for human consumption on the back end as well. So it's created in relatively verbose formats that we humans can easily digest. PowerPoint presentations, emails, all the types of unstructured document formats I mentioned earlier. So that's the first bullet point here, trying to describe the fundamental nature of unstructured data. It's of human origin, intended for human consumption. The next feature is that the majority of it is actually just contextual information. It's framing or elaborating on the actual hard key information. So if you really dig into what the bulk of the information in the email I'm sending to Kevin at work, it's mostly providing context for a given situation, the framing of a problem, the background history, justifying why a product feature should be designed in so and so way. But at the heart of all that context is the actual key information, which is a small subset of the overall information. And it's typically just that part that actually moves forward to the other broader parts of the organization or makes its way beyond the organization in the form of roll-ups and summaries. And because of that fact, and taking us to our last point here, most of the key information that we as humans are extracting from these unstructured data sources could actually be represented, if there were reason to do so, in a structured form. Now, when we humans are the ones doing the processing of the unstructured data, we're not going to necessarily extract the information so explicitly into a structured form. Why would we? But our minds do implicitly structure this key information as we're parsing it out of the sources we're reading. So let's take a concrete example of this. Like when a very important customer inbounds about a critical missing product feature that surfaced during their POC engagement with your company, the account executive reading the customer's email is going to implicitly sort of parse out some of that key information from the email and then relay that to the product team in order to help make strategic prioritization decisions. So that might be the name of the company, the size of the business opportunity, the feature that they're missing, the timeline they need the missing feature by. So maybe like 4 or 5 data points. We wouldn't really think of that as being structured data typically because we process all of that information fluidly. We implicitly know that these are the key factors of information that would affect the product team's decision on whether or not they prioritize the missing feature. So we include them without actually necessarily realizing the implicit structure of the data that we're communicating in the process. So the ultimate point is this: there's often implicit structure underlying all the key information that actually gets processed and leveraged by us humans when we're dealing with all these various unstructured data sources. And that's the basic premise of our new document data extractor feature. And that is, its goal is to help organizations that want to tap their unstructured data in order to realize the AI productivity gains we discussed earlier, offered by the plethora of agentic systems and automation tools out there. In other words, with this tool, we want you to be able to more efficiently, on behalf of your organization, process your unstructured data and convert that into business action. So for example, can messy contractor invoices be autonomously processed? Can product features ideas be auto-magically parsed out of customer discovery calls and moved to the product team's backlog? The path forward is about building that bridge between messy, human-authored content to actionable, decision-ready intelligence that autonomous systems can leverage reliably. So that requires 3 deliberate shifts for organizations to undertake. First, organizations need to shift their automation mindset beyond just structured data pipelines into the unstructured data domain. So treating docs, emails, chats as first-class event sources. Secondly, in order to make AI actionable, the gap between messy data and decision-ready intelligence needs to be bridged. And that happens by understanding the data that's involved with the business processes and what is needed to make decisions around a given workflow. So you can think of this as the minimal data points required to take action in a given business process. Third and finally, there needs to be an investment in pipelines that actually transform unstructured data into an expected structured form, and then to use that information to then take business actions. So by tapping into your organization's unstructured data as a source for greater automation, over time, your organization should reduce the friction and drag from a lot of your business processes, allowing organizational decisions and actions to flow end to end with greater ease and lower latency. Okay, so with that framing, let's begin to take a look at our document extractor, its features, and how it compares to our core document transformation. So we'll start there with our core document transformation capability, because it's easier to kind of understand the new feature in contrast to it. So on the left, we have an example of a scanned, hand-filled medical document. It's pretty messy. Kevin and I have seen far worse, but it's still among the more challenging that we come across. On the right, you can see a visual rendering of the output from Unstructured's document transformation process. So with standard document transformation, we're basically just converting documents from one format to a more digitally accessible format. And in so doing, we're striving to achieve more or less 100% semantic equivalence with the original document. So we're capturing all the important semantic information. We may not necessarily capture every little bit of layout information, but we generally capture all the generally important information. So this is, of course, a visualized form of this document on the right, but our raw outputs are typically going to be in JSON format, which is sort of more universal in nature and is easier to convert to downstream sort of system-ready format. So, of course, there's options in our platform to convert to either HTML or Markdown. In this example, I've chosen HTML, and then I've added some styling and just rendered it visually. But I'll go ahead and actually show what the raw HTML looks like as well, which you can see now on the right-hand side. And some might say, wait, aren't you already sort of creating structure with this current process? And the answer, of course, is yes, but the structure is really just mirroring the original document. So it's structuring it, but it's according to the original perceived structure of the source document. But if you actually want to get this data in a format that's like ready for a database, it typically needs to be in the form of key value pairs. And as you can see here, there's no actual like association between patient name and the actual patient value. In this case, Marissa Donovan. So how do you actually achieve that? And that's where our document data extractor feature comes in. So as you can see here, whereas our document transformation engine structures the document according to its original layout structure, by contrast, our document data extractor extracts data according to a user-defined data model. In other words, bring your own data model. So let's take this document, for example. Let's say for a given medical research project, you are analyzing tens of thousands of spinal surgery operations and their corresponding documentation. So you're trying to answer the question of how prior medical conditions, maybe comorbidities, which are basically a name for that, and prior procedures are affecting medical outcomes for a given surgery. So for this research, you don't really care about the document structure, of course, nor large portions of its content. For example, why would you need insurance information? That's not really relevant to your project focus. So you probably only care about the person's age, maybe their gender, prior procedure information, diagnoses, and of course their comorbidities. So you might define this data model, which is basically targeting all of that key information. And then because of that, you can also mirror the expected format of whatever downstream systems you're going to be sending the data to. So basically a database or some sort of blob storage. So as you can see here, the fundamental difference is that the data is extracted into a clean structure of key value pairs, which make it immediately actionable for downstream systems and agentic systems. Okay, so those are the rough features, but what kinds of technical problems does the data extractor solve? So I'm just going to focus on the high-level technical use cases. Kevin's going to actually share some case studies or real-world examples at the end. But the first most common like technical use case is what we just saw. It's really like this named field extraction, creating these key value pairs where they're already sort of implicitly implied in the document source. Another powerful feature is normalization. And I have here table normalization, but really sort of any sort of data normalization can actually be achieved with this tool. So if you're attempting to aggregate data coming from different sources of information, let's say from different vendors or different application forms, each with slightly different representations, you can actually normalize that process during runtime with this system versus what would typically be a downstream reconciliation process. And if we have any data engineers on the call today, I'm sure you can relate with how tedious and time consuming that task can be. So here you can actually do it sort of automatically. And of course, there's other features, document page classification. You can categorize or classify whole documents as well as down to the page level. You can create page level indexes of the type of content. That's great for retrieval systems. You can do intelligent segmentation of the document and so on. So these are some of the more common technical use cases we've heard, but of course there are dozens more. So with all that being said, I'd like to actually go ahead and jump into a quick demo of the tool. So here we are. So with our ETL Plus platform, we've made it super easy to get your unstructured data from point A to point B, transforming, enriching it, and now extracting data from it along the way. So the platform, as you can see here, features a robust UI, but of course, all the full functionality is also available via API. So if I jump into the workflows here, and this is assuming you've already created your connectors both upstream and downstream. So we're going to go ahead and jump into the workflows here, one I've pre-made for this demo. It opens up into our workflow builder. And you can see now here the long-awaited document data extractor in action. And of course, it appears in the UI as a drag and drop node in our workflow builder. So here's how it works. First, you would define your target data model. So we're going to go ahead and click on it. And then here it says schema. You could also call it a data schema. And it's going to open up. And you want to be thinking of this in terms of what are the fields, the names, and the format that you want to specify. So in this case, we're going to define this patient object. That patient is going to have different properties, and that those properties are going to be name, birth date, sex, so on and so forth. And of course, medical summary, same thing, prior procedures. Those are going to have properties, what the procedure was, the date, and so forth. So you can additionally basically provide a schema extraction prompt, as you can see over here on the right. And with that, you're basically done. And all you need to do there from there is basically connect your source repository. So this can be anything like from an S3 bucket to Google Drive, SharePoint, whatever your organization uses, wherever those documents reside. And then downstream, basically wherever you want to send that extracted data to. So if we want to actually open a document here, you'd actually just upload one. In this case, I'll upload this one. It does take a couple of seconds to actually upload, so I'll just go ahead and jump to the output. But you can see here the form we saw in the demo earlier. And then on the right, if you see here, I'll highlight it. Here you can see the extracted data according to that data model, that data schema that we specified. So that's more or less how it works in practice. And with that, I'm going to go ahead and hand it over back to Kevin to walk you through some use cases. Kevin?
Awesome. So like Daniel said, wanted to walk through some of the things that we hear in the wild. The first is a tax automation platform. And the challenge they were bumping into is they ingest 1 million tax forms every month, and they have a 25% failure rate. So 250,000 documents were having to be sent to a human in the loop workflow, which was offshore. And like the business challenges here is that is slow and it was very expensive per document. And even with a human doing this extraction, it wasn't 100% accurate. And so with very little work from our team to build out the schema and to create the prompt, they were able to like dramatically improve their accuracy, which reduced the number of documents they actually had to send offshore, which created a tremendous amount of business value. Do you want to go to the next one, Daniel? We also had a chemical manufacturing company that was looking to automate order processing. They currently do this today using a SaaS platform, but it's costing them about $1 million using legacy extraction technologies. And they still were only getting a 70% accuracy. Another wrinkle in this use case is that they had to support 14 different languages. And so they were a bit apprehensive on how our VLM would do. And one shot without a lot of expertise into these languages or like the structure of these invoices. And they were able to see dramatic improvements. And the cost was a fraction of what they were currently paying to do this today. I think that's probably good because I want to save some time for questions. Yeah, this is a great point in the call. If you do have questions and you want us to answer them live, we're happy to get to those, but we can start off with some of the pre-submitted questions. How does the extractor handle extracting a key value that has different names depending on which customer sent the document? Daniel, any thoughts on that?
Yeah, so we actually sort of touched on that with the normalization technical feature of the extractor. So really that would just basically be entered into the description. If you remember the schema where I defined the formal schema, for a given field, you can actually include anything from a very lightweight description of what that field is to actually a pretty verbose like prompt about like all the different variations that field might have. And so you're essentially able to normalize the data despite all of its variations as it's going through the pipeline.
Awesome. Thanks, Daniel. What are
Mhm.
some successful applications of Gen AI in data science, apart from general text to SQL and coding assistance? So, at a high level, all good data science products rely on good quality data. The usual suspects for what we hear on our side is like RAG applications, so knowledge-based chat your docs is really common. With the structured data extractor, we're seeing more and more critical workflows that we can automate with a higher accuracy and a much cheaper cost. And then we're hearing more and more about truly agentic workflows in the wild. So those are kind of the common use cases that we support. How to tackle complex layouts and tables, nested rows, semi-structured tables, regular layouts. This is a great question, and we feel very strongly about tables. We did a webinar 2 weeks ago that I might direct the question asker to that dives really deep into this topic. All right. For teams who traditionally relied on manual review of documents, where should they begin with automating workflows using LLMs? I think at a high level, like you should just look at the most common workflows in your organization that are being run by the most number of people. Daniel, I think you actually went through this exercise here at Unstructured. So do you want to speak to how you thought about this?
Yeah, I would say the strategy that we use and what I would actually recommend is to actually crowdsource this. I mean, you don't necessarily know as an individual in your organization what all the other employees are struggling with in terms of pain points. So basically tapping everyone in the org with a questionnaire or some sort, what would be awesome to automate in your sort of job function. Then you can actually basically build spreadsheets and prioritize what the use case is based on that.
Awesome. Daniel, what happens if the document includes handwriting? I know you kind of showed that off in the demo, but like, what's your
Yeah.
experience with handwriting?
Yeah, so that's one of the awesome things about sort of this VLM-based technology that's underlying a lot of unstructured technology. And it's really that, it's seen everything under the sun. It's been trained on the world's data. And we've built sort of fine-tuned prompts and also different other strategies to make it so that handwriting is basically sort of a non-issue, whereas with previous systems, they would basically just fall down whenever they saw complex handwriting or sort of messy handwriting.
Awesome. How can small and mid-sized businesses take advantage of this, even if they don't have a dedicated data science team, or more realistically, if the data science team is underwater with a number of other responsibilities?
Yeah, I mean, I think that's actually where our tool shines is that we try to make it as easy as possible. I mean, the hardest challenge will probably be creating that data model, but honestly, you can use our documentation and the help of ChatGPT and probably get pretty much all the way there. Maybe have someone sort of like look over your shoulder just to make sure everything looks good. But yeah, and then the automation tools, like as you saw, we had a graphical user interface. You can just kind of stick with that versus using the API. And then also on the downstream side, on like that automation tools, there's a lot of great tools out there like Zapier and N8N for doing automation that our tool can plug directly into.
Okay, I just opened the Q&A. We're getting a lot of live questions. So you want to do a quick rapid fire section, Daniel?
Sure, let's do it.
All right. How does the extractor handle large lists? 100 items in an array have run into problems to do it consistently and accurately.
Yeah, so we do have all kinds of features. Like it's not just like a VLM wrapper that we're using under the hood. We're doing intelligent like document splitting based on context window size. We're merging extraction results from different document extractions. So we have a lot of powerful features that basically help enable like data coverage and data accuracy.
Okay. Another one on the accuracy front. Does the document extraction tool provide an output accuracy evaluation solution out of the box? This is one of the biggest challenges with all things extraction, which is like, how do you effectively eval this? Typically, we will work with clients if you have a gold labeled data set that you can validate against to determine the accuracy. We'll use that. If you need us to help you in building that labeled data set, we can also do that. And we're doing a lot of work to simplify this process for our customers. Um,
I
how
see
do
one actually that it's how do you handle a file that contains several documents inside, for example, a loan file?
Mhm.
That was actually, if you remember slide, I think it was slide 13, a few slides back on the technical use cases. When you're actually doing the document, basically like indexing of per page content, you can actually tell like, okay, on page one, it's roughly this information. On page two, it's roughly this information. And you can actually categorize those to a given, like if you know sort of for a loan file, like this is going to be a W-2 versus like the actual mortgage information, right? So you can actually classify each page to a given sort of like enumerated list. And then that enables segmentation. So you can then like split the document into its component subdocuments, which is a really cool feature. And it actually has a pretty broad applicability for different use cases.
Awesome. Thank you, Daniel. We are at time. I want to say thank you so much for all the engagement and the amazing questions. If you still have questions, feel free to book a call. Daniel is always standing by, ready to chat. We will be here next week, and thank y'all so much. Bye, everyone.
Thanks, everyone.